Hey everybody, in this video we are looking at example 6 in section 4, exponential and logarithmic equations in the unit on exponential and logarithmic functions. Here we're going to focus on how to solve logarithmic equations. We've been solving exponential equations until now. Now we're going to have to take a different spin on things when we're solving logarithmic equations. One strategy is to change your equation from logarithmic to exponential form. So those are the style of problem we're going to see. First, I have 4 examples here for us for example 6. Now, what do I mean by changing it from logarithmic to exponential form? Well, what I mean is the following. Logarithmic form is going to look something like y equals log base b of x. So b is a subscript, everything else is just regular text. And the equivalent exponential form is, the better name for it is really exponential form of a logarithmic equation. It's going to be b to the y equals x. Now, if x is inside log, like it is right here, to get it out, right, to free it from where it is, we need to implement the inverse, which is exponential. And if we rewrite it in this form, the x has sort of been freed up and it's no longer trapped inside the log. Whereas in the previous maybe 5 examples, right, we were solving for the exponent, and in order to free up the exponent, we needed to implement some form of log, whether we took the ln of both sides or used the concept of log by asking ourselves the question b to the y to what power equals x, and going from there. All right, and then the base is either the base of the exponential or the base subscript of the logarithm. So let's see how we do this and how this ends up being beneficial. Example 6, solve. Now this one's pretty straightforward. It's already set up for us pretty nicely. Solve log base 4 of the quantity x plus 3 equals 2. So this is already set up pretty nicely for us. Now, just to color code a little bit, the base right there. Okay, so I have the base already straightforward. I have where x is, which is inside of the logarithm. It's just a composition where instead of x, like an f of g of x, where the g of x is x plus 3. So instead of having log of x, we have log of x plus 3. So really we're working with a form of a composition, and our y is the 2. So when I'm in this form, which is the form I have written above, just in reverse order in a way, I want to change it up into its other form. So 4 to the 2 equals x plus 3. And what that did is it freed the x up. 4 to the 2, 4 squared is 16, equals x plus 3. Subtract 3 from both sides, and x equals 13. Now, another thing that we're going to have to do is log does not have a domain like exponential of all real numbers. So we're going to have to check that our answers make sense and that we can, in fact, plug them back in. So we're going to want to always make a habit of checking your log equations. You're going to, with time, become better at knowing, which case is really important to check and which it's maybe you can get away with kind of like not fully checking. But if I plug it in, 13 plus 3 is 16. I know that I cannot take the log of 0. That is not allowed. And I cannot take the log of a negative. That is also not allowed. And since 16 is neither 0 nor negative, I am good to go. The final answer is x equals 13. Let's try another example. How about this one here? Now here, we got to deal with this 3 because it's kind of floating around in the way, and I need to, kind of get rid of it, if you will. Like it's got to move, it's got to go somewhere else, right? So how do I deal with this 3? Well, we can either use power property and put it back on the 2x. In that situation, it would really go here, and you'd have to raise the 2 to the 3rd and the x to the 3rd. And frankly, that makes solving a little bit trickier. So I do want to avoid doing that. Or I could divide both sides by 3, which I think is easier. So the 3 is going to reduce out right over here. the ln of 2x, or natural log of 2x, equals 12 over 3, which is 4. Don't forget the base of natural log is e. So now I'm in log form, right? There is, oh boy, there is the x. My base is invisible e, and the thing I'm taking the log of is 2x. So I'm going to go ahead and write this in the other form. E to the 4 equals 2x. Well, almost done. How do I get x alone? If I want, I can just take e to the 4 over 2, which is also 1/2 e to the 4, and that is x. I got x alone, one way or another. We're all done. And if I plug that back in, 2 times that number, it's not negative or 0, so I'm good to go. We are perfect. So that's the answer. Obviously, if you want to use a calculator, you can use a calculator and get the decimal if the directions ask you to do so, but I'm going to leave that as it is for now. Now let's look at checkpoint 6. For checkpoint 6, it's just like example 6a. So we will rewrite 2 to the 3 equals x minus 4. 2 to the 3 is 8 equals x minus 4. Add 4 to both sides and x equals 12. Take that 12, plug it back in. 12 minus 4 is 8. That number is good to go. It will be totally fine. You're done. And lastly, divide both sides by 4. Get that portion alone. So ln, or natural log of 3x, equals 2. Rewrite it. E to the 2 equals 3x. So that means, let's even go up here, x equals either e to the 2 over 3 or 1/3 e to the 2. Both are the same thing, and we are done with that. So I hope these examples were helpful in explaining how to handle a logarithmic equation in one of these forms. The next video we will be looking at when we have to maybe use power property, product property. Well, we could have used power just now, but maybe more so using properties, power, product, quotient, something like that, to clean it up before we move into the phase of example that we were just doing, right? So we'll see that in the next example. If that was helpful and you're happy and mathy and you know it, thumbs it up. If not, thumbs down. Questions, comments, concerns, requests, and feedback in the comments. Check the description box and the playlist at the end screen for more videos on this topic, organized for you in every which way. All right. Bye for now. Adios.